So in problem 5 and 6, and I'll do 6 on the next page, we're going to be dealing with distance problems, and like simple interest, there is a formula that you need to know. It's distance is equal to rate times time, and we always check to make sure that the time is in hours, and distance and rate can vary with their units depending on if it's in like kilometers or feet per second or whatever. So I would recommend also that you draw a picture of this one, and that'll help you to first set up the problem, and then also when you get done you can come back and check and make sure where was my X and be able to evaluate really easily. So we've got that a plane flew from home to the maintenance facility, and then it flew from the maintenance facility back home. And we have information about how long it took him, a little bit. It does say that it took 1 hour less time to get there than it did to get back. And since we know less about the flight from the maintenance facility back to home, we'll let it be X. And then the flight there took 1 hour less, so we're going to take X and subtract 1 hour. We know that on the trip to the storage facility or maintenance facility, it was 220 miles per hour, okay? And then on the way back, he was flying at about 200 miles per hour. Notice our question asks for how many hours did it take, and that helps us to see that yes, this X is representative of the time, and it's in hours, okay? So now let's go ahead and set up our formula. And we know that distance is equal to rate times time once again. And what we want to do is we want to make sure to think about which of these variables is actually equal. And so that will help you to set up these distance problems, because you can either make them where one side is equal to the other, or you can make them a combination of two things. So if it was finding the total, then we would have been able to add them together. But since this one doesn't say anything about like the total time, or it does say how many hours did the trip take, but it's not, we're not combining the two trips together to make one big long trip. So I bet that we need to set two things equal. And so if we think about flying from home to the maintenance facility and then from the maintenance facility back home, both of those values are actually equal. So what we want to do is we want to say the trip there, so from home to the maintenance facility, is equal in distance to the maintenance to home flight. And so we can actually fill in the formula, rate times time, for this one on this side, on the left-hand side, to find the total distance that was flown. And then we will fill in the rate times time on the right-hand side, and we know that those two distances are equivalent. So we'll do that. The first one, we have 220 times x minus 1. And that is the expression that represents rate times time, okay? And then we're going to fill in over here, we have 200 miles per hour for an unknown length of time. And when we solve, and we'll go ahead and do that, we can distribute through and go ahead and write this. We notice that we have x's on both sides. Now, you might be tempted to move your x over here to the left-hand side. And then if you do that, just be very careful, because if you subtract 200x like this, that's fine, but when you get done, you have 0 left over here, okay? And that, we'll keep going with this, and so we're going to subtract 200 here, and we've got 20x minus 220, but that's still equal to 0. So if you do this, if you move everything to the left-hand side, that's fine. We will have to move the 220 back across so that we have x's just on one side and variables on the other. So notice now if I divide through by 20 to get rid of the 20 in front of the x, I will be left with x is equal to 11. And then we look back at our problem, and here's x, so this is equal to 11. And since it's in hours, we can say 11 hours. And that was for the flight back. So we do need to make sure that we answer the question, and the question did ask about the trip there. So it actually only took 10 hours to fly there. So that was one type of distance problem, and now I'll move on to another one. So in our second distance problem, we will once again need distance is equal to rate times time. And what we're going to look at here is this like the last one? Do we have two things being equal in distance or equal in rate or equal in time? Or do we have maybe something else? So we have information about Callie who left school. So we'll put school here in the middle. Always, like I said, it's a good idea to draw a picture. So she left school and she traveled at a rate of 40 miles per hour. And then Matt drove in the opposite direction. So I'm going to label this one as Callie. And this one is Matt. Okay. And he left 1 hour later, and he traveled in the opposite direction with an average rate of speed of 50 kilometers per hour. Oh, and I put miles per hour over there. No worries. I can erase that really quickly. So we have both Matt and Callie's rate, but what we don't have is the time, at least for Callie. It doesn't say how long she drove for, and so we will just label her length of time that she drove as X, and we'll say hours. And then we know that Matt left 1 hour later, so if he left later, he drove for less time, and so we have X minus 1 hour for Matt, for his time. Now, we want to find the number of hours that it takes for both of them to drive in opposite directions and be eventually 400 miles apart, or 400 kilometers apart. So, in this one, we know she's driving at 40 miles per hour, and she drove for more time, but he's driving at a faster speed, but has spent less time on the road. So we can't assume that their distances are equal. Instead, we can think about this 400 miles as a total. And so what we want to think about is we want to say Matt drove part of the way, or, part of that 400 kilometers, and then Callie drove part of it, and we have a combined total of 400 kilometers driven. So now we can just use their rate and time to fill in the distance formula for both Matt and Callie. So we've got 50 miles or kilometers per hour times X minus 1 hours. And then we have 40 kilometers per hour times X hours. And now we can distribute and solve. So we have 50X minus 50 plus 40X is equal to 400. And then we can combine like terms on the left-hand side. So we have 50x plus 40x, which gives us 90x. Minus 50 is equal to 400. Then we can add our 50 to both sides to get x on a side by itself. So we have 90x is equal to 450. Divide through by 90, and we get x is equal to 5. And that represents Callie's time driven in hours. So we have 5 hours that Callie drove. And we know that Matt drove for 1 less hour, so he only drove for 4 hours. And then we make sure that we answered the question, and it says find the number of hours that Matt drove. So, yep, that's the one we needed. Don't forget, with the distance formula, sometimes the problems are not necessarily going to set the distances equal. Instead, they might actually put where their rates, so they're traveling at the same rate of speed, and those two things are equivalent. Don't forget that you can always manipulate formulas and solve for different variables. So if we wanted to set two rates equal, we would simply just need to solve for rate, and that would require us to divide through by time on this side, and then we could just leave it as rate is equal to distance over time, so that we have it solved for rate, and we could fill in, if we had two rates being equal, we would fill in the distance over the total time that it took equal to the other distance. So we'll call this one distance 2 over time 2. And so if we wanted to set the rate of one person traveling equal to the rate of another person traveling, that's how we would set it up. So don't forget that you can always manipulate variables. On this very last slide, what I thought I'd do is give you the opportunity to try this mixture problem by yourself. And you can check your work by interacting with these VAPs that are over here on the side of your screen. And so if you click on one of these, what it'll do is it'll pause the video and you'll be able to answer the question. It'll tell you if you're right. And then when you come back to the video, you just have to hit play again and it'll continue on. There's nothing more for you to watch because I am done, but if you'll click on one of these, just so that you can work it, it should let you stay on this page and you can check your work.